Okay, so hi again. Thank you for attending this last presentation of the day. So, in case you were not at the previous presentation, I'm Pierre-Marie and I work at IDECOR. And so this presentation will be about a small IDA library to read TOML files. So, what is TOML exactly? Let's first describe what it's not. It's a format. It's a text format to record data basically. It's generic, just like XML, JSON, and YAML, which I will compare it to. So, in XML, everybody knows XML. It's a format that is more or less easily written and read by humans, more or less, because if it's a bit verbose. And one of its defaults is that it's expensive to process. It's a complex format, and writing an XML parser is a big job, and it's very hard to get it right. Not only to write the parser, but then to write something that uses a parser because of the format complexity, such as the namespace feature. Validation is cumbersome because basically between tags you have text, and well, when it's spaces it's fine, it's just indentation, but when you have extra text, is it valid or not? It's complicated to check that an XML document actually conforms to some given formats. There are tools to do that, but they are even more complex. So well, XML is something that is good for some purposes, but it has these defaults. So another widely known format is JSON. JSON is actually is also very easy to read and write for humans. It's very easy to parse for machines. There is a specification for that, but it has, again, some shortcomings, such as, well, this document is invalid because you're not allowed to have a comma at this place, and if you have some experience writing this kind of document, you know that having this comma is handy because you don't have, when you add a new entry, you don't have to add it there. Anyway, it's handy. JSON does not allow strict JSON because some implementations can be more permissive. There's no provision to write comments. I'm sure there are other problems. So, and there are several known gotchas. So you may know that JSON comes from JavaScript, and in JavaScript the spec does not make a difference between integers and floats, so basically everything is a float. And so when you're writing numbers in JSON, you don't know what's the precision that the implementation will use to represent your numbers, so you're not sure that your numbers will be preserved, basically. It's a big issue. Another widely known format is YAML. So it looks like actually it's a superset of JSON, so every JSON document is a valid YAML document. It's easy enough to write, but actually the format is very complex and adds a lot of subtleties. So it's not very, depending on who you ask, it's not a format that you can write things in and be confident in how it will be interpreted from the first look. And yes, you have several annoying gotchas. Strings are not, there's no need for quotes. So generally you write strings without quotes until the string you want to write is some magic keywords, such as null, which will not be a string. It's going to be interpreted as a null value. So it's not very nice. So after this quick tour of readily known text formats and their defaults, their issues, there is TOML. So it's a file format. You have an example here. It's a file format that looks a lot like INI files, the old format that we mainly used on Windows and some configuration, mainly in configuration files. So TOML has been created specifically for this use case. It's very easy to read, and I mean it has obvious semantics. So here you have a mapping. Title is an entry that is it has a value that is a string here. You have first class dates. Dates is it's a native type to this format. It's mainly oriented as a mapping between keys that are strings and values that can be anything. Other mappings, arrays, and numbers, and so on. You have booleans. Anyway, the format has a specification. It's not formal, but it's very precise, and so it's quite easy to know if to read the spec and to actually know how to parse and write documents. And yeah, so it has a lot of good properties that make it a good candidate to use TOML as a file for your configuration, your software configuration, and sometimes just to record data. So that was for the TOML language. I didn't invent it, so this is the canonical home for the project. What I did, on the other hand, is yes, sorry. So I told you it's used for configuration files. So in the real world, most of the TOML uses I could find were package managers. So the main one is, I think, is Cargo, the Rust package manager, and other package managers for other languages also uses TOML. And as you probably saw earlier today, Allier uses the TOML format as well. Yeah. And so Ada TOML, it's an Ada library. It's very simple one to read. I mean, to parse and to create TOML documents from scratch. So I've written it actually for Allier because we were looking for a file format that would be easy to read and write for humans and machines, to describe packages. So this library has two very simple jobs. First, take a stream of bytes and parse it and convert it to in-memory data structures, containers. And the other job is to turn these containers back into a TOML document. So there are two parts in the library to fulfill these jobs. First, you have the definition of the data structures, the containers, and subprograms to actually do the parsing and the dumps. And the project is on GitHub, so if you want to have a look, this is the project's home. So, and this is where, yeah, okay. It's cut, but no big deal. So the first part is the data structures, the containers. It's very simple. You have two types, so TOML value and any value type. So TOML value is what could be any value in a TOML document. It could be a table, a mapping between key and values. It could be an integer, a string, or any other data type allowed by the TOML format. And you have this enumerated type that describes what's behind a TOML value. So is it a table, an array, a string, a date, an integer, boolean? Could be anything. And you have this function kind that takes an existing value and returns what is behind this value. All right. So you have naturally functions to create values. So if you want to create a TOML value that is a boolean, you call the create boolean function that takes the actual value you want to store inside a TOML document. You have the same for integer, tables, and so on, and also functions to add an entry in a mapping, all sorts of operations you would like to do with containers. So that was to create values, and you have the corresponding other operations to actually read the values behind the TOML document. So here the asBoolean function takes a value, and assuming that this value holds a TOML boolean, it returns the corresponding Ada boolean. It's a precondition, so otherwise you have an assertion error. Yes, I said earlier in the slides, it's an Ada 2012 library, so we can use preconditions there to actually be specific about what are the requirements for each function. So it should be quite natural. Well, this library does not do anything complex, so it's supposed to be very easy to use. Yes?
We have three create integer, create string, and create table functions. Why are they not simply called create with different types of parameters?
Because that would... Yes, well, it's a personal opinion, but I have the feeling that having multiple constructors, the only way as a human to understand which, so you're talking about overloads, having multiple functions, having the same
type anyway?
Sorry?
Don't we return the same type anyway?
They do return the same type, but
yes,
they...
But you can't overload them.
Yes.
I can because they're part... Yes.
Yeah, okay.
But when you have...
Yeah.
The thing is that when you have... because of the shape of this... wait, let me...
You get the best of both worlds. If you name the parameters, then you replace your function create integer.
Yes.
Your function create, and the parameter is called from integer.
Yes, well...
Then with named parameter association,
actually,
you say create from integer arrow for
that works for the atomic data types. That doesn't work for arrays and tables because you have constructors that just create empty containers. So for tables and arrays, that doesn't work. Indeed, it could work for the atoms, so booleans, strings, integers, dates, and so on. But so I have the feeling that if you do that, if you rely too much on overloading, the code ends up less readable because as a reader, you have to, I mean, if you have create integer and provide it directly an integer literal, it's quite obvious what it's doing. But if you have, if actually instead of 42 here, you have other calls, other functions, anything more complex, your brain has to work a little bit more to know what it's doing actually.
You can name the parameter from integer arrow.
But that's right. And then you have to rely on actually coding practices to make the thing the more understandable possible. Yes. Anyway, so this is what using the API looks like to build values. So it's quite straightforward. Here we create an integer, a string, and then an empty table, and then we fill the table with the values that we just created before. And so if you're familiar with JSON, when the execution reaches the comment, you have in T a document that is equivalent to this JSON document. And here you have a small example of what converting TOML values back to native ADA values looks like. So that was it. With that, you can create TOML documents programmatically without parsing any TOML. But then, so yes, first, still in the TOML package, the main package that defines containers and so on, you have two functions to actually convert a string to a TOML value, and the other way. So, well, it's not directly returning a TOML value because when there is a parsing error, you want to actually return an error. I decided not to use an exception because of various practical considerations, such as the ADA standard does not guarantee that the message that you associate to an exception will be preserved. I mean, you don't have any guarantees regarding the length. So for error messages, it's not great. And also, anyway. Also, in the read results also contains the source location of the error. I mean, it could be in text, but I prefer to keep it as numbers. Anyway, so that's quite straightforward to use. There is another package that actually allows you to do this the same, but instead of dealing with TOML documents, strings in memory, it goes to the file system. And finally, if your TOML documents, you don't want to read it from memory or from a file. For instance, if you want to get it from the network or from a compressed file, well, there are generic subprograms that just abstract the stream of primitives to read or write the TOML file to and from an abstract stream. And that's it. So again, here is the project home. So this library is already available in Alaya. And, fortunately, because Alaya requires it, so it would be a shame if if it wasn't registered there. There is only one release. It's a very young project, and as far as I'm aware, the only serious use of this library is Alaya, the Alaya project. But still, it's the first release is. I mean, the API probably won't move much, except if I rename constructors. But that's another debate. And so you're welcome to have a look, and if you want, contribute. Thank you. And if you have questions, I will be.
Just a remark, there is another benefit of TOML that you didn't mention, is that you have no closing bracket. So, no, it's very important, because if you want to accumulate results in a file, you cannot do that in YAML, because when you've closed the bracket, there is nothing you can do after that. Take a tool like, an example, ADA control, which, by the way, can have its output in TOML format. Then you can run it several times and accumulate the result in the same file.
Yes, the text concatenation also works from content, a valid document concatenation.
Yes, absolutely. And that's something you cannot do with YAML.
Yes, that's right. Well, that works from the for the maps. Actually, it depends. I mean, it works for the top-level document, for the top-level mapping, but you can have nested. You have a syntax to create nested tables, but well, that doesn't matter. Another thing I didn't mention about this format is that it's specified. Actually, it's not a text format; it's a binary format in the sense that it specifies that all documents must use UTF-8. So you don't have to worry about encodings when you use this library. More or less. Because when you provide it a string, it's assuming that it's a valid UTF-8 string. Other questions? Yes?
Are you also the author of Connect called JSON, or did you just take some inspirations from it?
I took some inspiration from it. Actually, I'm one of the current maintainers of gnatcall.json. Yeah, I think the API, some part of the API were easy to use. Yes, yes. I didn't. Yes, actually, the part where when you parse, it doesn't raise an exception but returns a structured error, a first-class value error. It's the part I contributed to gnatcall.json. So.
Okay, thank you, Pierre-Marie.
Thank you very much.